All right, so we got revenue 35 x to the 9/10 minus, I'm going to put a parenthesis here, negative 0.066 x squared plus 30x plus 740. All of that's going to be over x. And the reason it's over x is because the average profit is going to be revenue minus cost over x. So that's going to give us 35 x to the 9/10 plus 0.066 x squared minus 30x minus 740 all over x. Now, this is your average, and they want you to take the derivative of that function. So go ahead and take the derivative of that function using the quotient rule. So denominator times numerator prime, and I'm just going to write that in blue. So that's going to be 35x to the 9/10 plus 0.066 x squared minus 30x minus 740 minus the numerator is going to be 35x to the 9/10 plus 0.066 x squared minus 30x minus 740 times the denominator square, or denominator prime, all over denominator squared. So I'm going to delete this over here. And that's going to give me x times, and I'm going to do that in green. So I'm taking the derivative. And that's going to be 9/10 times 35 over 1 x to the 9/10 minus 10/10 plus 2 times 0.066 x to the 2 minus 1 minus 30. Y'all check me and make sure that's the derivative. Minus, brackets, 35 x to the 9/10 plus 0.066 x squared minus 30x minus 740 times x. All that over x squared.
You need a bracket on this end?
Yep, thank you. Now you can distribute that negative x if you wanted to at one time. And that's supposed to be a green x. Well, the derivative of x is what? Sorry, 1. So that's a -1 that you're distributing. And I'm going to erase this. I would not give you this question on the test because to me this is a lot of tedious work for learning how to do the quotient rule. I understand where they're going with this, but I don't think it's a good problem to do as a drill. I think it's a good problem to do as an application, but not trying to show you how to use the quotient rule. So x times, and I'm going to put this in brackets, it's still green because I'm still working with it. That's going to be, 10 will go into 5, that'd be 9 over 2. I'm trying to see, let's see, that would be
63 over 2.
Thank you. 63 over 2, and x to the -1/10 plus 2 times, what is that, 0.132, what is it?
0.132.
0.132 x minus 30, and then go ahead and crank that out. That's going to be -35 x to the 9/10 minus 0.066 x squared plus 30x plus 740.
Yep.
And all that's over x squared, yes.
Shouldn't that -30 have come? Yeah, topic 3.
No, the 740. The derivative of 30x is 30.
Okay, sure.
Yeah. And I'm trying to see if anything doesn't look like it. I was going to see if something might cancel out, but it doesn't look like it. So it looks like it's going to keep on going. So that x is going to come up, and I'm going to distribute that x. That's going to be plus 10/10. And right here, that's going to be x squared and 30x. Now we're going to see something cancel, I hope. So that's going to give us 63 halves x to the 9/10 plus 0.132 x squared minus 30x minus 35x to the 9/10 minus 0.066, that's supposed to be 66, x squared plus 30x plus 740. And the 30x is cancel. Don't the 30x is cancel? I think the 30x is cancel. And everything else is going to, so 63 over 2 minus 35. I'm going to put that over here. I'm going to do it with fractions because I don't want to depend on a calculator.
-7 halves.
Say what?
-7 halves.
You already did it?
Yeah.
You are gifted and talented. -7 halves x to the 9/10, and that takes that out. And then 0.132 minus 0.006, 0.066. Check it. Be plus 0.066. And plus 740. All over x squared. I don't know how far they want you to take it, but I mean, if I simplify it, they want it the long way. And if I don't simplify it, they want it simplified. So I have no idea what they want. So we're going to punch it in right here and see. And see if that's what they got. Yep. There it is. And then you plug in 170. I'm not going to ask you to do that. You can do that on your own. Okay? Let's get to another question. Now again, this is a good homework question and it's a good application question, but I wouldn't put that on the test because that's a lot of tedious work to learn how to do the quotient rule. Okay? I'd much rather give you that after you learned how to do the quotient rule. So with that being said, let's move on. I'm not going to complain about Tri-County. I'm not going to complain about Tri-County. 1.6, I think I just did that one, right? Yeah, I just did that. All right, this is 1.6. Same one? I can't see. Is it the same one? That's the same one. 57, 57, 68. This is 68/17. Now this is a test question. So you got to use the product rule, and then you're going to use the quotient rule inside the product rule. So go ahead and start it. That will be first times the derivative of the second, and I'll put that in blue. X squared plus 1 over x squared minus 1. That's where you're going to use the quotient rule. Plus the second, x squared plus 1 over x squared minus 1 times the derivative of the first. And that's going to be x to the third minus 8. All right, get to work. Give you a couple of minutes to work it out. Okay, so that might start you off a little bit. Mr. Miyagi, you concentrate. Hell, he's not even
I
awake.
don't know what to do.
What?
Nothing.
You're not working on the problem?
My tutor.
No. You already quit or you already finished?
It's like in between.
They're between?
Yeah.
I didn't know there was a between quit and, finished.
It's like that point where it's like you're almost there, but you don't remember what to do.
Or you just don't want to work. Which one is it?
No, I got some.
You got something, okay. X cubed minus 8. We might as well quit on this. There's just too much work.
Absolutely.
Too much work. How dare you give us one like this? So x squared minus 1. And what's the derivative of x squared? 2x minus parentheses x squared plus 1, 2x, over x squared minus 1 quantity squared, plus, and there's not much you can do here, 3x squared times x squared plus 1 over x squared minus 1. Now you need to focus on the green. I'm going to make this smaller. One of the teachers at Tri-County Tech asked me, why don't I give in-class tests in this class? And I said, do you teach online classes? Yes. Why don't you give in-class tests on your online class? She didn't say, always got to be somebody in the group, always.
Why not give tests online?
What?
I said, why not give tests online? I think that's a great thing.
Well, you got these teachers that don't teach very well, and they think that everybody cheats in their class. Well, you're going to have cheaters, just like you're going to have people steal something out of your... You can put a fence and a wall and a security system on your house. Somebody's still going to break in. You always got 2 or 3 idiots in the class that's going to cheat. But I don't care about those. I want to try to teach to those people that don't know. And if you have a comfortable environment for your students, they shouldn't, if you're teaching them something, they shouldn't cheat because they're learning something. Now, am I wrong or right?
Right.
I'm excluding lazy asses, okay? Because you're always going to have 2 or 3 lazy asses and they're going to try to cheat, and that's fine. Just whenever they get to engineering, they won't pass any of their courses. So, because they can't do the calculus. All right. So I'm still going to write in black and green until we get this green settled down a little bit. And I'm just going to distribute that 2x here. That's going to give me 2x to the third minus 2x. And I'm going to distribute this negative and this 2x at the same time. So that's going to give me negative 2x third. And what? Minus 2x over x squared minus 1 squared plus 3x squared, times x squared plus 1, x squared minus 1. And the 2x cubes, they cancel. 2x squared, so that's negative 4x. So that's going to be x cubed minus 8 times negative 4x plus 3x squared times x squared plus 1. I was going to get a common denominator. Let me just go ahead and rewrite it. I was trying to do 2 things at once. I better not do that. So, x cubed minus 8 times negative 4x over x squared minus 1 quantity squared plus 3x squared times x squared plus 1 over x squared minus 1. Now what do we need to do? Get a common what? Denominator. So I'm going to multiply the second one by x squared minus 1. So I'm going to do that in magenta. I'm going to multiply by x squared minus 1, x squared minus 1, and that's going to give me negative 4x to the fourth, negative 4x to the fourth, plus 32x, plus 3x to the fourth, plus 3x squared, and I've still got to multiply that by x squared minus 1 over x squared minus 1 quantity squared. And it looks like that I can take that x squared, good gracious, negative 4x to the fourth plus 32x, and that's going to be 3x to the sixth plus 3x to the fourth. Is that a minus? That's a minus, right? Minus 3x to the fourth minus 3x squared. Y'all check me, please. Over x squared minus 1 quantity squared, and 3x to the fourth cancel. Dang it, 3x squared was going to cancel, but I don't think it does. So that's going to give me negative 4x to the fourth plus 3x to the sixth minus 3x squared plus 32x over x squared minus 1 to the second power. I'm going to leave it right there. I have no idea. Y'all check my algebra. I could have dropped the sign in there somewhere, but let's see what they got. Three x to the sixth minus 4x to the fourth minus 3x squared plus 32x, and you feel good about yourself. How'd you come out, Pendleton? Easily?
I did good.
Everybody got it
Can you
right.
leave it up there for a second so I can?
Everybody got it right. Mr. Miyagi, is that your answer?
It is now.
It is now.
Yup.
Now you see why people can't do calculus. Because the calculus is right here. Rest of it's algebra. Okay? Got it? Whoever asked that, leave it up there for a second. You got it yet?
Yeah.
All right. Good test question right there. So that's 1.6, 68, 68, 68, 1.69/3. Use the product rule. Okay, I don't care about, I'm just going to do the product rule, okay, if y'all don't mind. And I'm going to cut this out while y'all are writing it down. I'm going to cut it out and put it on the whiteboard so I'll have a little bit of room. If y'all don't mind.
No, we don't mind.
I appreciate it.
No problem.
Pendleton, y'all don't mind, do you? Mr. Miyagi, y'all okay?
It helps my slanted eyes see better.
Oh, okay. Hey, you rough on yourself, Mr. Miyagi. You shouldn't be that rough on yourself. There we go. And that, of course, will be by the product rule. So, let's get to it. You could just quit before you even start. Besides, y'all don't need college anyway. 7 first times the derivative of the second, and I'll do it in blue. Z to the third minus 4z plus 5 plus the second times the derivative of the first. So 7 minus z squared. Do this in green. That's going to be what? Ooh, that's the wrong green. There we go.
Colorblind.
Yeah, I am. 3z squared minus 4. Now, what I should do is just do it all in one color, and say screw y'all, but I don't. Plus z to the third minus 4z plus 5 negative 2z. Now, there's no calculus, it's all algebra. I guess we're going to have to use our FOIL method, pronounce it however you would like. And that's going to be 21 z squared minus 28 minus 3z to the fourth plus 4z squared minus 2z to the fourth plus 8z squared minus 10z. (21 plus 4 is 25. 25 plus 8 is what? I have no idea. 33?
Yeah, 30.
So 33z squared. Negative 28 minus 107. That don't look right. Oh, that's 10z, sorry. I don't see another z, so I'll go ahead and write that 10z down. Minus 28. And negative 3 minus 2 is negative 6. Y'all check me. And that's going to be negative z, 6z to the fourth, plus 33z squared, minus 10z minus 28. Everybody get that? Say again? Well, I may be wrong. Let's check it. Y'all write that down, see if I got it right. So negative 6z to the fourth plus 33z squared minus 10z minus 28. And we'll turn it.
Wouldn't it be negative 5z to the fourth?
I've already switched now. You should have said something before. No, I will see. Oh my God, I don't even know what they're doing here.
Another one.
I'm not answering all those. So somebody tell me what the answer is, A, B, C, D, because I'm not going to go through all that. Which one is it? First times the derivative of the second plus the second times the derivative of the first. So this one would be what? Negative 2z. And this would be 3z squared. I don't care. I'm just filling it in so it can tell me. Okay, check all. I'm getting tired of fooling with why don't they just ask for the answer? Oh my gosh. I'm sorry you had to do this question. I'm sorry. This is just torture. I didn't make this question. Okay, is that the final answer?
Very first, you got 6C4 instead of -5C4, but the rest.
Okay, well, we just did a different problem. I'm sorry. Let me see what I did wrong.
It's just added times and real chambers.
Okay. Where's my problem? Where's my error?
I think it's -5z to the fourth.
-5z to the 4th. Oh, so I messed up on the last part.
Yeah.
Oh, I multiplied 3 and 2. Sorry. So it's supposed to be -5z. Well, I think that's what you were telling me, Mr. Miyagi, wasn't it?
Yes, sir.
Or somebody was. So 2 times 3, 2 plus 3 is not 2 times 3. Sorry. I do that every once in a while just to show y'all that, people make mistakes. Next, that's 1.69, 9,
Yeah, for sure.
9. Now, 11, 1.7. Please let this be chain rule. Thank you. All right, this is a test question, so let's do this one. Now, you do not want to do algebra on this one. You'd be doing a whole page of algebra if you took this, raised it to the second power, and raised this. That's to the second power, to the second power, to the first power. Yeah, you don't want to do algebra on this one. So first times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second. Four minus x to the fourth raised to the fifth power plus the second. 4 minus x to the fourth to the fifth power times the derivative of the first. 3x minus 3 squared. 3x minus 3 squared. There it is. Times 5. 4 minus x to the fourth power. And then what's the derivative of what's inside? -4x to the third. Plus the second. Two. 3x minus 3 to the first power times 3. So that's going to be that -4x to the third and 5. I'm going to pull that out. And that's going to give me -20x to the third times 3x minus 3 to the second times 4 minus x to the fourth plus 2 times 3 is 6 and 3x minus 3 to the first times 4 minus x to the fourth to the fifth. Now they might want you to factor out something here. So I'm going to factor out the lowest exponent on each. So the lowest exponent on the 3x, that'll be that one, and the lowest is that one. So I'm going to factor out And you could also factor out a 2. So you can factor that out also. And I'm doing this because I have no idea how they want the answer written with this book. So I'm going to factor out a -2. And I'm going to factor out a 3x minus 3 to the first power. And a 4x, 4 minus x to the fourth power. And let's see what that leaves us. So 10x to the third. And then 3x minus 3. And then that cancels. And then plus 3, or minus 3, sorry. Factor out a negative, that'd be a -3. -3. The 3x minus 3's cancel. And that leaves 4 minus x to the fourth to the first power. I have no idea how they're going to want this answer. I'm going to go ahead and see if I can simplify some of this in the middle, because this, I'm going to highlight this. This is the same. And I think we've done a problem like this before, and they did it different when the factoring out. That's going to stay the same. I'm going to focus on this middle part. And that's going to be 10, that'll be 30x to the fourth minus 30x to the third minus 12 minus 3x to the fourth. Be a plus, sorry. Y'all check me on that. And that'll be a 33x to the fourth. 33x to the fourth minus 30x to the third minus 12. You could factor out a 3 there, and that 3 can come out here. I don't know if they're going to do it or not, so let me make this a little bit smaller. So, -2, 3x minus 3 times 4 minus x to the fourth times 3, and that's going to be 11x to the fourth minus 10x to the third minus 4. And I'm going to leave it like that because I have no idea what they're going to, I don't know if they're going to take the 3, and you got another 3 right there, you can factor that out. They could have several things factored out there. So let's see what they got. Yep, 6 times 3 is what? Yeah, that's what they did. They factored out a 3 right here. And 3 times 2 is 6. 6 times 3 is what? 18. Now the signs may be a little bit off because I got a -2 out here. And they didn't factor out a -2. So the signs will be a little bit different. And you see the 11x to the fourth, don't y'all? I'm just making sure y'all see the answer. Y'all see the answers there. There's the 4. There's the 10. And there's the 11, but the signs are a little bit different. Okay, because I factored out a -2. Okay? So I would say everything above here, you know, this right here, everything above that line right there is pretty much standard, and then it can change down here based on what you factor out. Good test question though. I'll be lenient with this question because they factored out, like I said, they factored out a 3 there, and then they brought that 3 out here with this 3 and this 2. So, any questions on that one? Y'all not being very talkative today. Okay. Thank you for the communication. 1711, 1734, 10. 1734, 10. They just say square root of x squared plus 2. Anyway, they want to try to confuse you on this. Just plug the u in. So that's going to be x squared plus 2 raised to the what? 1/2. And that's going to be 1/2 x squared plus 2 to the negative 1/2 times 2x. 2x over 2 x squared plus 2 to the 1/2 power, negative 1/2 power. That goes out. So that's going to give you x over the square root of x squared plus 2. Now that's one way to write the answer. That's the way I would write it, but they may take the square root of x squared plus 2, square root of x squared plus 2, and that's going to give you x times the square root of x squared plus 2 over x squared plus 2, and then you could just leave it like that. So that may be an answer. I don't know. It depends on how far they go with it. That's a good test question. I just don't like that they're trying to trick you. They're trying to make you go, I don't know how to do that one. So, oh yeah, the teacher that asked the question also teaches this class, so y'all could have her. What'd they get? They got x over x squared plus 2. So they stopped right there. So make a note. If you see this problem, just stop it right there. Good test question. I just don't think they ought to try to trick you. Next. That's number 34, 35. I feel like I'm doing y'all's homework for you. 35. dy du, du dx, and dy dx. Plug and chug. Plug this into this, and then just do the chain rule. Another problem, all they needed to do was just write it the way you need to write it. So, u is equal to 3x to the 5th plus 2x to the 4th raised to the 46th power. 46, 3x to the 5th plus 2x to the 4th to the 45th power times 15x to the 4th plus 8x to the 3rd. And that's, I'm not even going to try to go do that unless you want to do about 30 pages of work. Jacob, or Jake, you do that for homework.
All right. We'll do.
Asian Jake's already done it.
Yeah. Asians are better at math.
Oh, are they?
Yeah.
Explain that guy in the wheelchair.
They wanted you to do dy du. Okay, so let's take the derivative of u to the 46th power. Everybody
You
got
call me
that?
Jake.
Now they're doing it step by step. Hold on, y'all. There you go. I didn't do the steps, I just did it. Now, what they're saying here is take the derivative of u to the 46th power, and that's that. Then take the derivative of these two guys, and then plug these two guys in here. That's what they're telling you to do. So it's easier just to do this. 46, blah, 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 46 minus 1, and then take the derivative of what's inside. Everybody understand what they were doing there?
Yeah, they're.
These are just the parts. All right, next one. So that's 1.7 what? 1.735. Okay, 1.747. Same thing. Now, but they want you to oppose f of g. Now, if you remember, in 109, f of g, you're going to rewrite f with a big set of parentheses. So f is big set of parentheses raised to the third power. And what are you going to do with composed of g? What do you do with g? You're going to plug it in. So that's 5x to the 6th plus 2. Now find the derivative of that. Using the chain rule, 3, 5x to the 6th plus 2 to the second power times 6, 30 times 30 times 30 x to the 5th. And 30x to the 5th times 3 is 90x to the 5th times 5x to the 6th plus 2 quantity squared. Now what are we going to do with that? What are we going to do with that? Plug in a negative 1. Well, negative 1 to the 5th power is negative 1. Negative 1 to the 6th power is positive 1. So that's going to give us negative 90. And 5 plus 2 is 7. 7 squared is what? So, I'm thinking a minute. Be 49,000, no, yeah, 49,000 minus 490. 49,000, yeah, 49,000, which would be 48. What is it? What does it come out to be?
Negative 4410.
Okay, 4410. I had my zeros off. Did everybody get 4410? Thank y'all for y'all's communication. I appreciate it. I'm pissed Pendleton off. They ain't talk forever. I cut into their TV time. It's all right, Pendleton. You'll be okay. What? Yeah, they're miserable because they're having to pay attention. 4410. Next. 1.7. 49. Is that the same one? It's not the same one. That's 47. It's the same type. But go ahead and try that one. class would go by a whole lot faster if people would communicate, but heaven forbid they communicate. So u is equal, g of x is equal, they want to find f of g, so that's going to be parentheses to the 1/3 power, and 5 plus 3x squared, so that's going to be 1/3, 5 plus 3x squared to the negative, what? Negative 2/3?
Yep.
Times 6x. And 6x divided by 2, or 3, is what?
2x.
2x times 5 plus 3x squared raised to the negative 2/3 power. And that's going to be 2x over exponent over index. And that's going to be, well, I'm going to bring it down. So that's going to be 5 plus 3x squared to the 2/3. Exponent over index, so that's going to be 2x over the cube root of 5 plus 3x squared raised to the 2nd power. So, plug in a 2, that's going to give you 4 over, and let's do this, let's see, 2 squared is what? 4 times 3 is what? 12. 12 plus 5 is 17. 17 squared is 2. I can't think of the 249. What is it?
289.
289. So, and what is the cube root of 289? I don't know if they're going to go that far or not. I don't know if you can take the cube root of 289. They may leave it as 289. I don't know how far they're going to take it. So let's see what they did. And they might have left it like this. I don't know. If this was a 140 class, we would take it all the way down and then rationalize the denominator. But this isn't 140, so let's see what they did. Yep, they didn't take it all the way. They just did 17. So make a note. They just plugged in the 17. And they put it to the negative. That's why mine's downstairs. You could do it right here. 2 times 2 is 4. That would be 17 to the negative 2/3 power. So it looks like to me you could just, let's see if I can do this. No, I can't. I suck. Question. And I know you're mad at me, Pendleton, but just look at it this way. You could be in that other person's class. Those of
She
you
that
that
bad?
still be. Huh?
She that bad?
What is it, like a 2?